Dave, you've brought me over to a different area here to see the walls being built. Where are we now?
We are at our climate control lamination shop. Let's head in.
Perfect.
We are at the Outdoors RV manufacturing plant in La Grande, Oregon. This is part 2 of the Outdoors RV factory tour, in which Dave, the director of manufacturing, shows us how the walls are made. And Matt even gets hands-on with one part of the process. If you haven't seen part 1 of the factory tour, watch that first. You can find the link in the video description.
We've just walked through the door there and I see a load of, aluminum going on here? What am I looking at?
Well, we have finished product. These are slide-out end walls, which all product, after we glue it, is a 24-hour cure. The first 20 minutes is 80% cure, but we want 100% cure before we let it go out into a non-climatized
sort of environment. So you bring the raw materials in here. This is kind of the holding zone for those to acclimate, make the walls, and then let them sit here again for at least 24 hours before they leave.
Correct, because raw materials have to acclimate to this building for a minimum of 48 hours. So it's at room temperature when we laminate it, so you have no delam issues.
Gotcha. I bet this building is like the most popular with the staff in winter when it's super cold outside, and it's really nice and warm in here.
Yeah, we have employees that wear shorts in the winter and they like their job.
I bet. It's really nice in here.
Yeah. This is where the sidewalls and rear sections begin as raw materials, as you can see. Right here, this aluminum's been acclimated in our warehouse. They brought it in and we'll start milling it to print. This is our aluminum mill. He'll take the raw stocks off of these E-racks, take it there. He has a print list, he cuts it to print, and then he will bundle it and put it on the roll carts for the next run that we're doing. We always try to stay 2 runs ahead so nothing gets rushed and missed.
Yeah.
Okay, you can see that this aluminum has been milled and it's being bundled. They do separate it in different stacks because, again, I mentioned that all our sidewalls have wood filling in them for the lag points for that second bite that we need to keep our stuff
super strong
and try to stay ahead of some of the competition.
So what comes in here as raw product, just extruded aluminum and foam and wood paneling, when it leaves here, it is completed wall sections ready to go?
Correct.
And that puts all the window cutouts and everything in here?
Yes, once it's laminated, we'll go through the CNC process where we make a laminated substrate look like a trailer.
That's awesome. And you're kind of you know what's going on in here, right? Because I hear you designed this entire building.
Yes, I did.
Why don't you continue the journey and show us what's next?
Let's go. Talking raw materials, this is all our wood fill right here that has gone through our wood mill, cut to length and dimension.
And what type of wood is this? What are you using?
We use different substrates for wood fill. On the floor, with the floor only being a 1-inch tube, we run plywood in there. You take a 1-inch piece of wood and you run a screw in it, you have a potential split.
Yeah.
That's why we use plywood down there.
Okay.
You can get our screw spacing, which we like to have 12 to 9 inches, without splitting that wood and losing your second anchor point.
Gotcha. And what about in the walls?
In the walls, we do use pine.
Pine. That's cool. So this wood goes inside?
Inside these tubes, on not every tube, just the wood fill tubes. Right here you can see that the wood fill for that second anchor point that's going, this is in a slide out back wall.
And so when the screw comes in, it will bite not just into this, but into the wood inside?
Correct. 2 anchor points. Electrolysis don't have a chance when we do that. If it does, we're still locked into the wood.
So I see a lot of different units here that all look very similar. They've been clamped together, I guess.
Yes, we stack weld. If we weld one frame at a time, it isn't as efficient. By stacking it, we can build, the bottom one's a jig, and he's building 1, 2, 3, 4, 5 front sections at once.
And gets them all really carefully lined up, and then just goes through and welds the whole lot.
Correct. And the bottom one is the jig. It's going to be built like the actual product, and then you're just stacking above it the proper tube. And then you just piece it together like a puzzle and then weld. And we do full welds.
So not just spot weld, but full weld down the seam.
Correct. On the interior seams, we do. I've been asked, why don't we weld this position here? In the lamination process, if you weld it on the front or back, when you lay the sheathing on it, that's going to act like a tent post. So from your tent post out, you're going to have a certain portion that you have no adhesion. We want 100%. Okay, one thing I didn't mention on this aluminum, when we do get it, it goes through an acid bath. A lot of extruded product, they're using a lubricant on it to run it through the dies. Well, after that process, they do run this through an acid bath for etching, and we need that etching to increase the dyeing level, which is a potential of adhesion, so we get a good bite.
On the weld?
On the gluing process.
Oh, wow.
On the gluing process, when the glue hits the aluminum.
laminate.
Yes. Now the other thing, we take a second step, which we'll go through later, is we also do a hand acid wash before we laminate too, because in this process, a lot of people have touched with their bare hands, and the oil of their skin will contaminate the potential for adhesion in that fingerprint.
So it gets totally cleaned down, so then when the laminate comes over the top, it completely adheres all the way across.
Correct. One thing that you notice is we run grid tables, and the reason for that we didn't cover there is after they stack, they have to clamp that to keep everything flush before they weld, and that's why these are grid tables. So it allows us to get a clamp down there and clamp those items together.
And what are we looking at here? These look like they're all welded in a stack.
These ones, they're not. They're actually welded side by side because the weld points are so close together. If those were stacked, the bottom one, you couldn't get the nozzle for the welder down in there to weld that particular item. And what that is, what that item is that is a skirt that goes below the slide out floor.
I hope you got a good bulk discount on clamps.
Yeah, we go through a bunch.
I bet.
Right here, this employee is building a roof truss, and everyone goes, where's that roof truss go? If we look at this A-frame cart behind it, that's the actual rear section. And with us running the trolley roofs, we have to have that roof truss incorporated in, and we went with aluminum on the rear section rather than wood.
And so he just bends that aluminum across.
Correct.
And then welds it in place. I guess what I'm looking at here is a stack of sidewalls, and I'm guessing this is the foam that goes inside them.
Yes, Matt, it is. This is a completed sidewall. Once I'll go through the wood fill process too. The rear section goes against this. The screw will be lagged into this. That is the reason we would fill this. That is pine. Again, with the top, which this unit is upside down when we run it through our process. This wood fill, again, is pine for the roof.
So then the screws come in and they bite really hard into that wood inside.
Correct. On the floor, because we use a thinner stick, this is where we actually use 5/8 plywood in there, so we don't have any wood splitting.
And then the screws would go in from this side?
They're actually lag bolts. They're 4-inch lag bolts that go from the up through the floor into the wall.
Wow. And then this foam, I'm guessing, is going to fill the cavity on here. Tell me about this foam.
Okay, one thing that I will mention is we don't use any recycled product. Our aluminum is virgin aluminum. Likewise, we don't use recycled foam because we want a density of 2 pounds on our walls for the integrity, because that's really the heart, the nucleus of our wall.
So this is not lightweight stuff though. This is pretty heavy, is it?
Yes, it's very heavy. You can see it's really dense. Then a 2 pound, 1.5 inches.
Yeah.
And again, this is not recycled foam, it's virgin foam. It's
Can I try and lift one of these? I want to see how heavy it is. That's got some weight to it. That is not packing foam or something.
Not at all.
That's serious.
Yeah. It has some weight, but it is lighter
Yes.
than a wood wall.
Oh yeah, definitely. And a lot better insulating as well.
Yes, the insulation value is...
How well does this insulate? How good is the insulation here?
Well, the best way I can describe it is we've all drank coffee out of a cup. If you can take a coffee cup,
Like a polystyrene cup.
Polystyrene cup that is 1/8 to 3/16 in thickness, and you can sit there and hold it with 212 degree water in it and it's not scalding you, that should give you some of the insulation reflective
This is
value.
even better quality foam, and it's a lot thicker than a coffee cup.
That's correct. This is one of the frames we just looked at. It's getting ready to flip over on the table to get the pre-cut insulation stuffed in all the empty quadrants.
So this is the entire sidewall of the trailer, from end to end. There's not multiple walls here.
Correct.
This
It's
is
a one piece.
Wow.
Some things that we do to increase the dyeing level, which again is protection for adhesion, is certain areas we will also sand and then we will wipe down with the anodyne acid to increase that bonding value.
And then when these are ready, they flip these over.
Yes, they'll flip them over onto a table, which they've done here. They will take the foam that has been cut for each quadrant and they will install that foam. What they do is they'll make a whole stack of just foam, because then they have adhesive that they have to deal with, so they don't have a glued up mess. Then they'll work down, and what they're working down is they're putting that electro galvanized metal on the coach, which you can see is the shape of our cabinets. That is the tie-in plates for all our cabinets. We tie everything from the inside out on a laminated wall.
So then when you put the screws in to attach the cabinets to the walls, the screws aren't just going into foam, the screws are actually going into the aluminum.
Correct.
And then the foam.
Correct. They're going through the wallboard, and then a second anchor port, which we need, is that electro galvanized steel stripping.
Oh, and it's steel, not aluminum.
No, it is steel.
I keep saying aluminum then.
Yeah. The steel, two things it does for us. One, it's a stronger anchor point than aluminum. And two, we can, once that wall's assembled, you cannot see that bonderizer. That makes it capable. We can run a magnet along the wall and search out where that bonderizer is located.
Gotcha. But these pieces on the side, these are aluminum, right?
Yeah.
It's just the strips that are steel.
Correct. And this is a slide out opening. There's no foam in it because that will be routed out. And all these are is a brace to keep our slide out opening square. What they're doing now is they're taping that foam in, because when you're going from a horizontal to vertical back to horizontal, if that foam falls out, it's chaos.
Yes.
They have 7 minutes from when they start the lamination process to where they finish the pinch process. That tape helps hold that foam in. When we go to lay the wallboard, the glued wallboard on, that tape will be removed because our lamination strength is only as strong as the adhesive on that tape. So it will all be removed and disposed of.
This is just temporary.
It's just temporary, just to hold the foam in. A lot of times, anytime we hang a TV, we don't depend on just the bonderizer.
Yeah.
We're going to actually laminate 3/4 plywood in that wall.
Oh, really? So where the TV mount would be,
Yes.
there's actually not even just a steel sheet, an
No,
actual piece of plywood.
it's actually 3/4 plywood.
Wow.
The TVs, with them hanging on the wall and going down the road, we need that something that's more rigid that's going to ensure you don't have a TV on the floor.
So then you'd screw through the wood panel, a little bit
Into
of
the
foam,
plywood.
and then into the plywood.
It actually goes from the wood panel, the plywood will be layered to where it's against the paneling.
Gotcha.
Yes.
And then here we have, I think the panel is now moving over, about to get stacked.
Yes, now they're flipping that wall again. It'll be right side up to where it can go over to the lamination table.
So those walls then are structurally really strong, but they're still light enough that 3 people can lift and move them on their own.
Yes. And the lamination, once we bond that rigidity will increase significantly. One thing I might mention here is we can see that the foam wall has these lines on it. What they do is, as they're foaming these, they laid a carpeted jig on that has slots in it. They'll take a felt marker and draw these lines. That tells them the center line of their bonderizer where they will install it. The bonderizers are adhered with high temp, high strength spray adhesive.
And that's the spray adhesive going on now.
Yes,
And then the people working here, do they work as kind of teams?
absolutely. Teamwork is crucial.
How long will one team kind of work together for? Do they stay on? Is this team always in this area?
Yes, this team is on the foam install crew, and they will stay there usually throughout their career, unless they're looking for advancement, and they will be looked at for that. Okay, Matt, this is what we call a harp saw. This is how we mill the foam.
Okay.
I've milled the foam with saws, but you get all the little pebbles.
Yeah.
If that gets in your lamination process,
It
temp
will
post,
bubble
it's not good.
Yeah.
We cut everything with a heated wire, and this, again, is a harp saw. Why don't you give it a try and
Wow.
see the simplicity of it?
I've been really impressed with how tight fitting the foam is over there. I'm going to do this on some scrap though, I think. It's probably safer. So then I latch that from there. And then that comes onto that.
That's just an armature wire with a DC voltage in it to where it heats up, and then it melts right through the extruded styrofoam.
And then back up. And then loop that round. Like that. And then I should have. Hey, look at that! I did it!
Nice,
What do you think?
Nice clean cut.
It is. That's a really clean cut. That's really smooth.
Foolproof.
Just about. Just about.
Yeah, good job, Matt.
Thank you. So Dave, we've seen the stack of walls get assembled now. What's next?
The next process is they will shift over to where they will actually have the substrates put together through our lamination process.
Can we take a look at that?
Absolutely. This is the heart of our system. This is how we apply the thermal hot melt glue to the substrates for assembly. A thermal hot it's similar to a hot melt gun, but this being a hot melt that's reactive, it only reacts one time. You can take it from a solid to a liquid. It will cure back into a solid. Unlike glue guns,
Yeah.
you can actually take a match and reheat the glue. This is a
is
one-time
set.
deal. What we depend on in this is A, temperature, that's why it's climate controlled, and B, humidity. Humidity is a catalyst that activates the glue to cure.
Interesting.
The glue will, upon being demanded from the switch, will come out of what they call a platen. We get them in 400-pound drums. It goes up through these lines, and then we'll go to the application rollers. Okay, we're at the beginning of the lamination. This is our layup table. What they're actually laying up now is a rear section. So what they've done is they took the outer sheeting fiberglass panel, they put it there, they blowed it off. We want no dust particles killing the glue. So they're blowing that off, and what they're going to end up doing, we'll watch, they're going to call for some panels. The application rolls will apply the poly hot melt in a thin film, which we try to get around 12 grams per square foot. Here comes one now. They got their alignment point. That's a Luan sheeting double coated because it's got to stick to the pylon and the frame. They feed that second sheet out. 2 4x sheets make 8 foot, and that is an 8 foot rear section.
And they have to move quickly in this area because of the time the glue
They have to
can be.
move quickly. Once that first sheet goes through, they have 7 minutes to put the last sheet on and run it through the nip roll at 70 degrees room temperature. We can get a little bit more open time if we run the temperature up in the room. But the trick is, they're building a 8-foot by 8-foot wall now, they have the same amount of time as if they're building a 30-foot wall to get the substrates on. Now they're setting the frame of the rear section. They're removing that masking tape because we want our bond against the frame and the bonderizer, not against masking tape.
Yeah.
When you see them leaving, they're actually unloading off into these tables, which I might give you a little background on it. There's blowers on these tables, and there's perforated, and they act like an air hockey table to where they can move that item without A, scratching it, and B, a bunch of strain on their back.
Yeah.
He's laying a paper up on the top there. That's because they'll put foam in there. That overhang, if it does, when it gets pinched, you have to have that foam in there to get a full pinch on it, so you have no delam at the top
on the edge.
Yes. Now they're putting the wall board on. This gluing process, unlike a lot of gluing processes, you don't have to glue A and B. You only have to glue A. Then this particular rear section will go through a nip roll that puts 8,000 pounds per square inch of pressure to transfer the glue line from A, the wallboard, to B, the foam and frame.
And to this press here, that's the heat press that's just adhered all those together.
Correct. That's how you get your glue transfer.
And then they're going to slide these down here and stack them up, and that's where they'll then sit for another 24 hours.
Correct. In our warehouse, then they'll go for the line for assembly. That's why it's crucial. This building is a minimum of one run ahead of the line.
So that wall unit now is totally sealed. But I'm sensing there's a problem, because we need to get some windows and doors in here. So how do we do that?
We'll come down, I'll show you. Okay, this is our CNC machine. It's kind of unique in CNCs because it's 10 foot wide and 45 feet long.
It's huge.
Right now, there's routing the windows in the slide out end walls. What they're doing is you have to have a 0-0 point. The computer, once you line up that, it sees everything on the table, and then it's just a push of a button.
And how does it cut the holes? What's it using to cut those with?
It's actually using a carbide double-edged bit.
So with all of these wall sections, you're cutting these pieces out. What do you do with the leftovers?
Some of them will actually be used in the trailer as a component, such as under your dinette cushions.
That panel that's under the cushion?
Correct.
That was once one of my windows.
Yes, that was one of your windows. What he's going to do is on this next one, about every fourth route out, they do a pull test on it. And that's what I'm going to have him do.
And what does that mean? What do they do for a pull test?
What they did, it's actually, they will try to separate the glue bond to see how good an adhesion that we got on the product.
Even though it was only just done a few minutes ago,
Correct.
It's already strong enough.
Absolutely. It's strong enough for a pull test about 15 minutes after the gluing process, because you have 80% of your adhesion is complete.
Wow.
Okay, what he's doing, he's actually putting a putty knife in there to start that panel to tear. What he's looking for, there, we have 100% adhesion.
So, and we know that because the foam itself is still stuck. It's actually the foam that fell apart.
Correct.
Not the foam bonded to the...
Yeah, there's no shiny spots. If you notice when that glue comes out of the machine, it's shiny. Now it has that dull color. That's because that is foam that's actually stuck to the glue line.
Wow.
We test that for potential of delam. We try to eliminate it. If we end up having something that it turned out, the red flag goes up.
Yeah.
During our process of lamination, we record what unit of glue on, what lot number of glue. That way we can find which component is failing and we can eliminate it off our line, so we kill it then.
And how often do you do these tests?
These pull tests they'll be done about every fourth route out on the end walls. On the trailer, we do on a full sidewall. We're going to do the front, the middle, and the rear section, because the front was the first panel.
Yeah.
And the last panel is at the rear, and then we also test the middle.
Wow. On every single one? Or
Every wall,
four?
every wall.
Wow.
Every sidewall we check, front, back, and middle.
So when it leaves here, you know it's bonded. You know it's.
That's correct.
In the third and final part of this Outdoors RV factory tour, we will see how the rest of the trailer is built. If you're new here, this was Matt and Diana, and you're watching Adventurous Way channel. We are on a quest to visit all 400 plus national park units, and we're doing it by living full-time in our Outdoors RV 21 RBS travel trailer. Subscribe to see part 3 of the factory tour and more Outdoors RV and national park videos.